This video will discuss Sybase database level replication, MSA, and warm standby. In this series of videos, I want to take the next step to understand Sybase database administration, and that is to actually explain how Sybase features and functions are used in practice and can provide interesting solutions to common problems. So I won't provide Sybase commands or give details on setup. My target audience for this video series is a DBA already familiar with Sybase terminology and concepts. First, about myself, I've been a Sybase DBA for over 20 years in the financial industry, so I have a good understanding of how fast-paced companies use Sybase ASC and replication server. I've been using ASC since version 11.5. So let's get started. In this video, I will discuss Sybase database level replication, called MSA replication, and warm standby replication. They're not the same, but often get confused with one another. I've even heard MSA described as the better warm standby. This is not accurate, as each has its own purpose. I will discuss how we can use both of these to provide value or solutions to application problems using the database. And this is really the most important thing a DBA can provide. So first, MSA replication. MSA stands for multi-site availability. It allows you to replicate a single source database to one or more targets. It's a very flexible database level replication solution. You can exclude or include specific tables, stored procedures, and system stored procedures like SP_rename. MSA replication is set up using repdefs and subscriptions, just like table of replication, so it is a bit easier to set up than warm standby, which uses either rs_init or rep server configure commands. The replication server for the source database can be the same or different from the target replication server, as long as there's a route between them. So the target database and the replication server it uses can be in a remote region compared to the source database. Warm standby is also database level replication. The replication is set up in a single replication server and is built on a logical connection in the rep server. This allows the rep server to treat two databases as one. There can only be one source and one target of replication in warm standby. The source side is called active, and the target side is called the standby. There is not much flexibility in specifying objects to be replicated or excluded from replication like in MSA. Warm standby replication is set up using the replication tool rs_init or configure commands from the replication server. The feature that really distinguishes warm standby from MSA is switch active, basically reversing the direction of replication, making the standby the new source. I'll discuss this feature more in later slides. Here are two of the similarities between MSA and warm standby that I think are important. Both MSA and warm standby can use dump marker functionality to start the replication and sync the target from the source while the source is still being used. This feature allows synchronizing the source and target without the need to have the application stop activity in the source database. The synchronizing is done through database dump of the source and a load of that dump into the target. And rep server will keep track of the point to start applying transactions to the target based on the last transaction that was captured in the full dump. Basically, it means using dump marker allows you to sync the target by dump and load without worrying about losing transactions, even if the source is still actively being used. In warm standby, the dump marker functionality is invoked when creating the standby connection. In MSA, the dump marker functionality is invoked when creating the subscription. Syncing the target database is a task which will appear many times once replication is set up, so it's very important to have this functionality for full database replication. The second thing worth mentioning is that both can also be used with table level replication. Tables in the database with MSA or warm standby replication can also have repdefs and subscriptions to other databases. In warm standby, the repdef definition specifies the logical connection of the source database. So you can see how complicated a replication system can become if you aren't careful. One last thing I'll mention is that MSA can be used with warm standby, just like table replication, but I'll leave the discussion to some future session. So how can warm standby help us? Going back to warm standby and switch active, this allows the DB to switch the direction of replication, which means the active and standby database switch the roles and the replication flow is reversed. This functionality is fully supported with a single native command and described in replication server documentation. Warm standby and switch active can be set up and used to help us with things like upgrades, migrations, and disaster recovery. So for upgrading ASC to major version and providing rollback capability, we can set up the active side on the database we want to upgrade. Say the database is ASC 15.7, and the standby side is on a new ASC 16 data server. On upgrade day, we switch the direction of replication and have the application point to the new ASC 16. So I'll show a diagram describing this basic idea in the next slide. For data center migration to new hardware, we do a similar thing, set up the active on the current source and the standby on the new host. On migration day, switch the direction of replication, and we have the database on the new host. For disaster recovery, we just need to make sure we set up the active or current source and standby in different data centers. The general idea for all three of these cases is that we can drop and recreate the standby database and place it wherever we need it, and use that target as a potential replacement for the source, with the old source serving as a rollback database with all current data. The next few diagrams show these three cases. And one other thing, the warm standby change of replication direction is independent of interfaces file update, which is important because if your company uses a single global interfaces file, as many large companies do, updates to the file may only be allowed at certain times, which may not match the time you need to update the data server's entries, which is needed in the MSA case. So in our diagram above, the application is using 15.7 database. We want to upgrade to a 16 data server, so we set up warm standby replication to the new database. We perform switch active to make the ASC 16 database the active side, and the application starts using the ASC 16 database. The replication back to the 15.7 database provides all the latest data to facilitate midweek rollback if needed. This is usually only for critical applications which cannot afford extended downtime if midweek rollback is required. What is not shown on the following diagrams is the timing of each step. All of the replication setup can be done the week or the weekend before the actual upgrade. This will save time on the cutover day as the database is already there and the replication is already set up. So DBs can focus on other things they need to do to take care of on the upgrade day. Normally, a week or two after the upgrade, when the ASC database is confirmed to be good, which means no rollback is needed, the DBA can drop the 15.7 standby database and reset the standby on version 16 so that you still have the same version standby database ready in the future. This is one of the best ways to use warm standby. And in this diagram, we see the case of the migration. Basically, it's the same idea. The application using ASC 16 database in this case. We want to migrate the database to a better, newer hardware. So we set up warm standby replication to the new database on the new host. We perform switch active to make the ASC database active, and the application starts using the 16 database. The idea is the same as upgrade. After the migration to the new host, you can drop the standby if you don't need it, or you can move it also to a newer host. So just in case you need it for rollback or disaster recovery. And the last case I wanted to bring up was disaster recovery. We just need to make sure that the standby is in a different data center. This scenario was the most common reason people have used warm standby historically, to provide disaster recovery solutions, and as an added benefit, commonly advertised, was that it also provided a reporting database as a two solutions in one for setting a warm standby. I normally would put the rep server that manages the logical connection in data center 2, so the rep server can hold as many transactions as possible if they haven't made it to the standby database yet. in a disaster scenario. So using MSA. So switch active is not available using MSA. It is possible to change the direction of MSA replication, but that requires about 10 steps to do the same thing that running one switch active command will accomplish. It also requires interfaces file changes. 10 steps means more complication and more chance of errors and more downtime. However, it can be done, I just wanted to note. MSA can be used to set up database bidirectional replication to certain applications that would like to update both source and targets and keep both databases in sync with each other. This setup can also be used as a kind of high availability solution where the target database is already set up for replication and can be used immediately. MSA can also be used to set up hub-spoke type replication where, for example, the source is located in New York, where all writes occur, and replication sends the data to read-only targets which are originally located in London, Hong Kong, etc. Only the rep server writes to the read-only copies with updates from New York. But as with any replication setup, the more complicated the setup, the more difficult to maintain. The next diagram shows a high-level view of this setup. So for the New York database is where the all application writes occur, and replication pushes these changes out to the 3 regions. All applications write to only the New York database. So the New York application writes to the New York database, and the Hong Kong application writes, or the regional applications write also to the New York database. But all application reads will come from the local database, which will help performance on the reads. You can see that there may be a problem with latency since you need to wait for the writes to propagate to the local database, but this is just one scenario or one possible setup for MSA. So these use cases I presented are not exhaustive, but it should give you something to think about how database level replication can be used. And so that is all I have for my presentation today. I hope you enjoyed it. Be on the lookout for my next video in this series, the Advanced Sybase DBA.